students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. In this session, we will discuss the principles of green chemistry and methods of green synthesis. So this is module 4 and outcome 5. So here are the principles. Design for energy efficiency. In continuation with the previous session, we will go to the next principle, design for energy efficiency. Then safer solvents and auxiliaries, green methods, use of renewable feedstocks, then use of protecting groups or reduce the derivatives, then catalysis, design for degradation, real-time analysis for pollution prevention, and inherently safer chemistry for accident prevention. So these are the different principles that involved in the green chemistry. So the first one is the preventing waste, we have already discussed. Then the reactions, and the next comes the energy efficiency and all this. So we will discuss in detail, and also we will give we'll have an introduction to the methods of green synthesis that has to be taken place, how the green methods or the synthesis is modified to obtain environment free with pollution. So coming to the design for energy efficiency, this principle lies wherein energy requirements should be recognized for the environmental and economic impacts and should be minimized. It means the energy requirements for any process should be minimized such that it does not affect the environment and economically. So it means the pollution should be reduced and also the cost should be reduced. Synthetic methods should be conducted at ambient temperatures and pressures. It means any methods that we are modifying in the green chemistry, it should be in such a way that they can be accessible, or the process can be takes place in the presence of an ambient temperature or pressure, so that we don't give more temperatures that will reduce the energy. So there are different types of energies that are available, renewable or non-renewable energy sources. So by solar, water, wind, geothermal and biomass, these are the different forms of renewable energy sources, whereas the non-renewable energy sources are oil, coal, natural gas and nuclear. So these will be depleting from the earth crust or the environment upon its usage gradually. So if we are using for longer time and more energy is required using these resources, then they will be depleted in the nature or environment. However, renewable resources are available abundant in the nature, that is solar. If we use solar energy, it is widely abundant. We can convert solar energy into electrical energy and use it, or the water, that is from the tidal or water energy, from the water also we can generate energy or the electricity and use it. Wind, geothermal energy and biomass, these are naturally occurring and depletion capacity is low. So during this chemical synthesis, what happens? We have to target minimizing the energy requirements so that the cost will be reduced. And if the starting material and the reagents in a reaction mixture has to be heated to reflux for a required time, the time that is required to be kept minimum, so that the usage of the fuel will be reducing or the energy will be reducing. So for example, if we have a reaction mixture that has to be refluxed, then the time should be minimum, so that the use of energy, what we are supplying here, heat, we are supplying heat, that either can be done on a hot plate or a Bunsen burner. So in that case, what happens? We are giving heat energy from either electricity or from the flame. So in either ways, energy will be reduced if the time is reduced. So in this way, we can reduce the energy that is being given to the particular process. And use of catalyst has a great advantage of lowering the energy requirement of a reaction. What is the role of catalyst? That fastens the reaction fastens the chemical reaction mechanism. So it will speed up the reaction. So when it is speeding up the reaction, it will reduce the time and also the energy input. This is how we can modify the method so that the energy can be reduced. Then in case the reaction is exothermic, it means it is giving off heat, giving heat. In that case, what happens? We need cooling. So when it is exothermic, we need extensive cooling. So that also adds cost to the product that we are ultimately manufacturing. In that case, what we have to do, that exothermic reaction can be modified so that the cooling capacity can be changed. If the final product is impure, the other case is if the final product is impure. In the synthetic methods, we generally get impure final products, so that has to be recrystallized so that we get a pure form of product, So for this, we are doing some additional step like distillation, recrystallization or ultrafiltration. So all this will include energy again. So we are giving energy, heating or recrystallization, distillation, filtration, all these includes energy that has to be again added so that we get pure product. So by designing a process such that there is no separation or purification. So if for example we get a pure product out of our process without any recrystallization, then ultimately that reduces the cost, time and also the energy. So that is how energy requirement can be kept minimum. That is how energy requirement can be minimized. Energy to a reaction can be supplied either by photochemical means or microwave or sonication. So in this method, like in these cases, like in green synthesis, we can impart techniques like photochemical means of energy supply, so that for example, this is the conventional method, like we are heating in the mantle, whereas when we are heating in the microwave with the help of microwaves, then the energy requirement will be lowering. This is how we can impart different advanced technologies so that the energy requirement will be minimized. Then comes the safer solvents and auxiliaries. So the use of auxiliary substances are like solvents, separation agents should be made unnecessary, so should be avoided whenever possible, and if in case used, should be harmless. So whenever we are using solvents or separation agents, they have to be minimized to their use or should be used in a harmless ratio so that it doesn't affect the environment or the human health. So for example, if we see this diagram, there are two different solvents that are used. This is the conventional solvent that is used, ethyl acetate, for spinach extract separation. So it is replaced with some modified solvent, hexane. So what happens in that case? We are seeing the same separating speed. So it means that the solvents can be varied, or modified solvents can be used in different ratios so that we get similar separation as we do it with the conventional solvent. This is how we can improve the efficiency of separation and also reducing the solvents. So these green methods, then comes the green methods. Solvents selected not cause any environmental pollution and health hazard. So whenever we are using a solvent, we should select in such a way that it doesn't affect the environmental pollution, it doesn't affect the environment like polluting and also the health of humans. So the reaction should be carried out in aqueous phase so that it is safer to use. The reaction should be carried out using the without the use of solvent or solventless reaction. Another case, this is the case one where we can use aqueous phase, or it is a case two where we can where we can prefer solvent-like reactions. That means we are not using any solvent during that reaction. So the use of supercritical liquid or supercritical liquid like carbon dioxide should also be explored. So this is another case where supercritical liquids can be explored to give the same efficiency of chemical reaction and also avoiding harmful solvents. So, a better method is to carry out reactions in the solid phase. So, there are different technologies that are being explored. Even in the solid phase, the reaction can be carried out. So, that will give a better efficiency while avoiding harmful solvents. So let us see in detail. Like immobilized solvents can be used. So what are these immobilized solvents? That maintains the solvency of material, but it is non-volatile and does not expose humans or the environment to the hazardous of that substances. So this immobilized solvent like supercritical CO2 or the carbon dioxide will help in maintaining the solvency of that particular material and is also non-volatile in nature, so it will not be exposed to the person who is working or the labor, the exposure to the humans or the environment or the surroundings of the workplace. So this is how the accidents can also be prevented, avoiding the spillages. So for example, if we see decaffeination of coffee. So coffee bean can be decaffeinated in aqueous solution with water, or another one is the use of supercritical carbon dioxide. So what happens when we do just with water? It will be losing its flavors along with caffeine. So when we do with supercritical carbon dioxide, when we are passing the soaked coffee beans, high pressure is applied so that, and also supercritical carbon dioxide along with coffee beans, the caffeine is passing through the column, so that what happens, the caffeine can be recovered, caffeine is recovered, and water is also and they does not lose its other flavors. So, in the coffee beans, we have different flavors. Like we may have other ingredients that will impart a good flavor. So, if for decaffeinating during this process, it should not lose the other flavors. So that is the main aim. So therefore, there is another procedure with the supercritical carbon dioxide that can be used to remove caffeine. So if we see this picture, this is the difference we see when it is unroasted, it is like this, and when it is roasted, the roasted caffeine after decaffeination with supercritical carbon dioxide, this is how it looks with the dark brown in color. So this is one of the advantage of using immobilized solvents. Then comes the use of renewable feedstocks. What are the renewable feedstocks? We have seen in introduction, like these raw material or the feedstocks that we use should be renewable resources, from the renewable resources. That means from the biological origin. So that they do not deplete easily, and whenever technically and economically practical. So they can be used in large quantities and they are always producing. The starting material can be obtained from agricultural or biological products are referred to as renewable starting materials. So if we are using any material, raw material or the starting material from the agricultural based or biological based, then it is easier for us to move on for larger production, so that there is no question of depletion of these raw materials. So these are called renewable starting materials. But this has one disadvantage, that cannot be obtained in continuous supply due to factors like crop failure. This only happens like the supply will be stopped or will be in trouble only in case of crop failures. So in that cases only the problem will be like there will be some obstacles in continuous supply. Then substances like carbon dioxide and methane gas are available in abundance. So any process that includes these gases can be obtained from the nature, so that they are, because they are abundantly available. So these are again preferred for renewable resources. So therefore they are called as renewable starting materials. So, for example, if you see, there is wide applications for levulinic acid. So, for this, there is a method that can be used using renewable starting materials like paper mill sludge that is obtained from the paper mill, then agriculture residues and waste wood, any waste that is obtaining from agriculture and wood industry, then municipal solid waste and waste paper. So we see a lot of paper that is being wasted, so these can be recycled by using in the green methods. So this is also called as biofine process, where levulinic acid can be produced in this case. So this method of producing levulinic acid from agricultural waste or the renewable starting materials got a award like Green Chemistry Award in 1999. So this got good applications. This preparation got good applications, levulinic acid, in cosmetics, agrochemicals, then some solvents, and the plasticizers, fragrances, and polycarbonates, and other applications in the industries, wide applications in the industries like biofuels also. So with these, we can use it in many industries, and also you utilize and recycle the waste that is generated. Recycle or reuse waste. So this is more important. Like we are using the waste that is being generated from other sources and using for the recycling and producing new product. Next comes the reduced derivatives or protecting groups. So what is the use of this method? Like we are sometimes in the chemical synthesis using derivatization processes, wherein the particular group is protected so that the other group is used in the reaction. However, this unnecessary derivatization should be avoided, so that additional step will be removed. This is an additional step in the chemical synthesis. So additional step should be removed or avoided. So that how is it done? We can use some other modified methods. So we will see first what is this derivatization. If an organic molecule contains two reactive groups, for example, here we have hydroxyl group and an aldehyde group for the benzene ring, and you want to use only one of these groups, the other has to be protected. So we need only one to take part in the reaction, so that the other has to be modified or masked, so that that does not involve in the reaction. So that will give ultimate reaction completing and the protecting group to be removed. So after the reaction, the protecting group will be removed. In this case, the hydroxyl group and the aldehyde group is attached. So in this, benzyl chloride is used, so that this will go and attach to the hydroxyl end, so that this group is protected. So now on oxidation, again what happens? It forms a carboxylic acid, carboxylic group. So after an acidic medium, it is forming again OH. So the again producing some byproduct. So this has to be removed, and also the benzyl chloride, which is known to be a hazard and a waste that is generated from this deprotection, should be handled very carefully. So this again step 2, this is step 1 and step 2. Two steps are cost. These two steps will be adding cost to the manufacturing. So that is how it will be, like atom economy will reduce. So these protecting groups are added in stoichiometric amounts, should be removed once the reaction is complete. We have to take care and not included in the product. It should not be an impurity in the product, and this ultimately will reduce the atom economy. So The next one is the catalysis. So when compared to that, like giving a catalyst to the reaction, imparting a catalyst to the reaction will give better results. So these are better to the stoichiometric reagents. So this catalyst will perform transformation without consumed in the reaction and without being incorporated in the final product. So it is preferred whenever possible. It means any catalyst will do its job without involving itself in the reaction or getting into the product as an impurity. So for example, if we take a process in a stoichiometric process, this is how with the sodium bromide and water a reaction takes place, and there is again formation of byproducts or waste. So what happens? This is again a byproduct. We have to take care for recycling or removing the waste. But when it is in the presence of catalyst in hydrogen and palladium or the graphite, so what happens in that case? We directly get a product and not the byproduct or any no waste. So no waste. So we prefer generally this process when compared to the first one. So what are the advantages in this? Better yield, so that atom economy will increase, economy will increase because we are using all the atoms in that molecule in production of that particular product. Then reaction becomes feasible. So selectivity, it selectively reaction goes on and we get the product easily. And advantage in energy requirement, it is also reducing the energy requirement, better utilization of starting materials and minimum waste production. So these are the very good advantages that we get out of catalysis processes. So then comes the design for degradation. So once we get a product into the market, after its use, we throw out. So degradation is also very important to study before any synthesis. So the chemical products should be designed so that at the end of their function, they do not persist in the environment and instead break down into innocuous degradation products. So they have to break down into smaller molecules and degrade completely. So after their job, they should not remain in the environment. Pollution that will pollute the environment and humans. So products design should be biodegradable. So this is very important. The products whatever design should be biodegradable. Insecticides and polymers are non-biodegradable insecticides. So these are non-biodegradable insecticides like DDT. So that bioaccumulate in many plant and animal species and incorporate in the food chain. So what happens whenever there is a DDT that is draining off along with the rain, goes into the rivers, lakes, and that also interacts with the plants and animal species present in that river or lake. So when we use that water, that we also take in that polluted water. This is how it ultimately gets into the food chain. So some of these insecticides are responsible for population decline of beneficial insects. For example, if we are spraying insecticides and that remains in the crop, the fields, that will reduce the beneficial insecticides, killing them. So it is very important to produce biodegradable insecticides. For example, if we take any pesticides like carbendazim, this is used in crops. So this is microbial degradation takes place. It undergoes microbial degradation so that it forms 2-amino-benzamine diazole. So this is harmless. So like this, it has to degrade so that it does not remain in the environment, polluting the plankton or animal species. So that is how we have to produce some insecticides or the pesticides used widely, that to be biodegradable in nature. So these should be biodegradable insecticides. Then during degradation, what happens? They should not possess any toxic effects or harmful to the human health. So it is possible to have a molecule which possess functional groups. So for any insecticide to undergo biodegradation, the functional groups or the ending groups of that particular pesticide or the insecticide should be favoring degradation so that it undergoes a biodegradation process. So the functional group should be susceptible to hydrolysis, photolysis or other cleavage. So these are the reactions chemically that occur, chemical reactions. So what happens in this case? Either it should break the bond break with hydrolysis, photolysis in presence of light or other cleavage that takes place. So in that case only the degradation process will undergo. So how we can monitor, like for example, there are some microorganisms that are able to degrade. So we inoculate these microorganisms into the field and check the soil sample for its growth, or checking the growth of the degradation of that particular pesticide or insecticide or plastic, anything, insecticide or plastic material. For example, if we take a bottle that has to get degraded in the soil once we throw into the earth, so that sample has to be collected and analyzed for this study so that the peaks keeps reducing. That means enzymatic reactions are going on and the breakdown takes place indicating biodegradation. So, for example, degradation of polymers. Polylactic acid, this is used widely in making the crockery. So, these are manufactured from renewable resources. So, waste corn or wheat waste or agriculture waste are used in manufacturing the crockery from polylactic acid that is produced. So it uses 20 to 50% fossil fuels than the conventional plastics. It means it will use less fuels in degradation. So PLA products can be recycled and composted. So whenever we are doing or the manufacturing is going on with the agriculture waste, for example, this corn is used in making the polylactic acid. First it is made into starch, then lactic acid and polylactic acid, and finally the product is coming here. Crockery, for example, if we are manufacturing, we can compost one type of degradation, or we can decompose in water or carbon dioxide biodegradation. So this is how, if we see the biodegradation of polylactic acid, this bottle in first day will be like this, and after gradually the degradation will occur by 80 days. Within 80 days there is a degradation that is happening for this particular polylactic acid made crockeries that are generated from the agriculture waste. So this is how we design the products for better degradation. Then comes the real-time analysis for pollution prevention. So there should be some analytical methods that to be developed to allow real-time in-process monitoring and control prior to its formation of hazardous substances. It means any analytical technique to be used before it is giving out harmful substances into the environment. So that, like for example, sensors, if we are using that to be imparted in any of the products, so that during its life cycle, if there are any hazardous substances it is producing, the sensors will detect and give the results so that we monitor and control the formation of these hazards. These methods should be developed in designed in such a way that minimum usage of chemicals, so that they like recycling of some unreacted chemicals for completion of the reaction. So analytical methods should be so designed that requires. So these methods also should be designed in such a way that it requires less chemicals and recycling of unreacted chemicals. Like we can produce these methods from the recycling of unreacted chemicals so that it completely the reaction will be completed. Then Placement of sensors that we have discussed, like monitoring the generation of hazardous products during chemical reaction, is also advantageous. So for example, if they are using sensors, then it will give an indication that if there is any hazardous products that are producing during that particular chemical reaction. So this is how it will help the real-time analysis for preventing any pollution. So for a chemist, it is a process for checking the progress of chemical reaction as it happens, and knowing when your product is done can save a lot of waste, time and energy. For example, if we have a timer for cooking also, like it will help us in saving lot of wastage of food and time and energy. Like if for example, if we microwave the food, like we are setting a timer so that it gets switched off, so that the time is also reduced. The wastage, if it is burned, we have to waste the food, so the wastage is also reduced, and the energy, that is fuel or the electricity that we are giving input, will be reduced. This is how real-time analysis will help in reducing the pollution. Then comes the inherently safer chemistry for accident prevention. So we have seen a lot of accidents that are going on in the industry. So what happens? The main cause is recklessness. So what happens? The safer chemistry, understanding the chemistry is very important while working in the workplace. So the precaution, along with the precautions, so that accidents can be prevented. Substance and the form of substance used in a chemical process should be chosen so as to minimize the potential for chemical accidents, including releases, explosion and fires. For example, if we are using some substances that has to be used to be handled very carefully. For example, if we are using cyanide, that to be handled very carefully, otherwise once we inhale it or take in, it will cause death. So that is how we have to have the knowledge of chemicals that we are using, and also we have to use it in a minimum ratio so that it avoids gas releases, hazardous gas releases, explosions or firing. So that is how it will help in reducing the accidents. So the hazards posed by toxicity, explosion, fire, etc. might be looked into, and manufacturing plants should be so designed to eliminate the possibility of accidents. So what are the different possibilities? In larger plants, we will have smoke detectors. So that is how we have the sensor working there, so that it gives an alarm. And also it has to be designed in such a way that it eliminates the possibility of accidents. So whenever there are like chemical reactions taking place, it has to be near to some water or the sand, so that even if there is an explosion, that will be going to that sand or water, so that it will be minimized, the effect will be minimized. So if we see this diagram, green chemistry talks about energy efficiency, atom economy, benign solvents, renewable feedstocks, catalysis. And laboratory safety includes what is the normal laboratory safety. If we talk about chemical labeling, see, water also looks colorless and acid also looks colorless. So it is very important, like labeling the bottles, it is so that we do not take it. So safety equipment like personal protection equipment, mask, gloves and all, chemical storage, where the acids to be stored, where the solvents to be stored, flammable solvents should be kept apart. Then safety data sheets having a knowledge of that particular chemical. Then PPE, personal protection equipment. So these two together will get into safer chemicals, accident prevention and chemical waste. So if we really take care of these aspects, that will give us a result like safer chemicals, we can prevent accidents and chemical waste. So these are the principles of green chemistry. So if we see in the like a shortcut, like we can just remember productively and define all the 12 principles, like prevent waste, renewable materials, omit derivatization steps, degradable chemical products, use of safe synthetic methods, catalytic reagents, temperature and pressure ambient, in-process monitoring, that is nothing but real-time monitoring, very few auxiliary substances, E factor or maximum, feed in product, low toxicity of chemical compounds. Yes, it is safe. So inherently safer chemistry. So just remember productively a word so that you can just remember all the 12 principles at once. Then comes the methods that we use for the green synthesis or green reactions that will help and impart all these principles in helping this green synthesis. So chemistry plays a vital role to develop our quality life and achieve sustainability on earth. So keep on increasing the technology, we explore different technologies and improve ourselves so that the quality of life also increases. So all over the world using advanced knowledge to develop new synthetic conditions like aqueous phase, solvent free, microwave induced processes are used. It will help or favor in reducing the pollution in the environment. So for example, in green synthesis, we use biological components itself as reducing and capping agents. Therefore, reduction the overall cost in the synthesis process. Cost will be reduced. Cost reduced. Next, what in experimental conditions like high energy and high pressure are not required, leading to energy reduced. Energy reduced. Then what energy or the requirement of energy decreases. Can be used at large scale production of nanoparticles. So whenever we are using agricultural based or biological origin, there is always a scope for nanotechnology because the nature already has these nanoparticles or the nano level ingredients that can be used for our synthesis. Then eco-friendly approach can, like, as toxic chemicals can be avoided, or it will avoid the use of toxic chemicals so that it becomes eco-friendly or environmental friendly so that it does not pollute the environment. So if you see one of the reaction, example one, like reaction, what is that? Aqueous phase method for green synthesis. In this, environmental pollution is mainly caused by organic solvents. Organic solvents are very hazardous. Some of the organic solvents are hazardous, like polluting the environment. So now all over the world have been trying to carry out organic reaction in aqueous solution. So aqueous phase. So we are prominently looking for preferring the aqueous based reactions so that avoid the hazardous organic solvents. So the advantages of using water as a solvent is its low cost. Why we are using water? Because it's low cost, non-flammable, devoid of any carcinogenic effects, highly specific, heat resistance, and unique enthalpic entropic properties, and easily handled. So easy handling is also one of the reason, like water is used in most of the reactions so that it avoids some complications. So example is the Dundigal reaction. So where is we will see the conventional and the green synthesis, how it is modified. So, for example, the condensation of carbonyl compounds with active methylene compounds in the presence of weak base like ammonia, amine, pyridine is known as Dundigal reaction. So, here what we do, the conventional, this is the conventional reaction, that is like carbonyl group is reacting with active methylene compound malonic acid in the presence of base like ammonia, amine, or pyridine. So it will give the reaction carboxylic acid. So this is the one of the reaction that will be taking place. So how we are using here solvents Organic solvents only, amine pyridine we are using or ammonia we are using for basic nature. But when we really want to use a green method, how can we modify these? This can be carried out in water medium between aromatic aldehydes and acetonitrile. So if when compared to aliphatic, we can use aromatic aldehydes and acetonitrile, so that we can we can do the chemical reaction or the synthesis in the presence of water. So at room temperature, room temperature. So this is how the method can be modified, so that the effect of organic solvents like ammonium pyridine or amine group can be avoided. So here salicylaldehydes with nitrile is reacted together, will combine or react together in the presence of aqueous phase or water at room temperature. So this will give better efficiency, 75 to 95% efficiency. So the efficacy also increases. So this is how we are avoiding organic solvents in the reaction mechanism, so that the hazardous effects can be reduced. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.